Hello everyone, and welcome to a new video on this channel. And this time it's a follow-up to the previous video that looked at Gatekeeper and Kubernetes policies on AKS in combination with Azure policy. And be sure to check out that video to know what that is all about. In this video, we'll take a look at an alternative solution to implement Kubernetes policies, and that's Kyverno. Or at least I think that's how you pronounce it. Please correct me in the comments if required. But let's take a step back first and look at securing access to the Kubernetes API server, because before we have Kyverno kicking in, we have to first authenticate to our Kubernetes cluster. It has to know who we are. We either do that with certificates or usually with something like OpenID Connect. For example, you can integrate Kubernetes with something like Azure Active Directory. You also have to be authorized, of course, via Kubernetes RBAC. For example, if you'd like to create a deployment, you need to have that right to do so, and RBAC can give you that right. And then there's this concept of admission control, and that's basically software that looks at incoming requests and then modifies those requests or approves or denies these requests in real time. And of course, Kyverno plays in that part. Kyverno can do admission control, but also a little bit more than that. So when you're thinking about admission control, you have to also know about the admission chain. When a request is coming into the API handler, it is first authenticated and authorized, and then the mutating admission controllers kick in. Now, Kyverno can also do mutation. There's already a big difference with Gatekeeper, which cannot do mutation. And we'll see an example of mutation, mutating an incoming request later. Now, of course, a request that comes in always has to be validated. When you do a mutation on an incoming request, of course, after that, schema validation needs to happen. When that has been done, the validating admission controllers kick in. That's where Gatekeeper was used, but of course Kyverno here can also do that. It can be used to validate incoming requests and maybe reject them. For example, if you run a container as root, you might want to reject the creation of such pods. When the validating admission controller has decided that it's okay, then the request is written to etcd or etcd, whatever you want to call it, and then the Kubernetes controllers can use that information in etcd to, of course, make sure that the desired state matches the actual state on your cluster. A small reminder here about Azure Policy and Gatekeeper. So in the previous video, we had AKS deployed and we had Azure Policy as part of the Azure Cloud. The first thing we did was install the Azure Policy add-on. The Azure Policy add-on installs a sync component and also installs Gatekeeper for you on the AKS cluster. Now that sync component will then go to Azure Policy and look for policies that are specifically made for Kubernetes. In those policies, there are constraint templates and constraints, and that's exactly what Gatekeeper needs to know, right? That's how Azure Policy works. That's how Gatekeeper works. Now, of course, here there's a big limitation in the fact that Azure Policy has a built-in list of Kubernetes policies, and you can go beyond that list. You can't. If you want to go beyond that list, you have to not use the Azure Policy add-on and install Gatekeeper yourself and create a constraint templates and constraints yourself as well. Now, when it comes to Kyverno, bit of a different story here. Of course, there is no integration with Azure Policy. It's not made for that, right? You just install Kyverno on your cluster. Doesn't have to be AKS, but we will use AKS in our example. And then you create objects of type cluster policy, which are cluster-wide, or objects of type policy, which are linked to a specific namespace. And those policies can do different things. They can do validation, just as you did with Gatekeeper. For example, this could be in real time denying the creation of certain objects when they are not following the rules that you specified. But it can also be a mutation policy, a policy that mutates an incoming request. And we'll see an example of that later. Even above that, you can have a generation policy. That means that some other kind of object will be created. For instance, when you create a namespace, you want to create a network policy, a totally different object next to that namespace or for that namespace. And we'll see an example of a policy that uses the generation features as well. That's enough for now. Let's install Kyverno and let's look at a few policies and see how they work. I already installed Kyverno on my AKS cluster and I use the following command to do it. You can find this command in their documentation as well. There's also much more to say about the installation. That's not the focus of this video. So we'll just install it this way and then get started right away with the policies. After the installation, I started up K9s, one of my favorite tools to look at my Kubernetes clusters. And what you'll see here is that there's a namespace called Kyverno. That's the default namespace that's selected. And there is a pod running in there. You see the pod running over there. Let's get started by installing a couple of pod security policies. So if you go to the Kyverno website, which is kyverno.io, you'll find a policies link. There's a pod security link over there. Then you have the default pod security standards and the restricted pod security standards. For fun, let's just take the restricted pod security standards. And they've made it quite easy. They have these restricted standards all up on GitHub, and using customize and a kubectl apply, you can easily install them on your cluster, right? With Azure policy, we had to indeed create such a policy, which was an initiative, and then we had to make sure that initiative got applied to our cluster. In this case, we just copy the YAML. To apply this to our cluster, we just have to run the command that we just pasted, and the result will be that there are all kinds of cluster policies will be created. Let's look at a cluster policy that denies privilege escalation. So this was installed on our cluster already, so we can get it and then output the YAML of that. Let's do that. And the YAML is actually shown here. And let's look a little bit at the anatomy of such a policy, because there's quite a lot of stuff in there here. So what you can see first of all is that the API version is kyverno.io/v1, and this policy is a cluster policy. So it's a cluster-wide policy. Now we're gonna not look at all the stuff which is in here in the annotations, but let's go to the specification. So the spec here has rules. And that's typically how it works. The spec of a policy has rules, and there can be different rules. And these rules, they use matches to match the policy to certain kinds of resources. So in this case, this policy matches with resources of the kind pod. And we call the actual policy deny privilege escalation, right? We also send a message when we see that indeed there's an issue, that we can actually say, look, privilege escalation is disallowed. Now there's much more here, right? But one of the important things, of course, is to look inside the YAML and look at, did you actually ask for a privilege escalation? And that is done here in the pattern and then the spec of the pattern. It looks in your init containers and it really needs to know that this is false, and it looks in all your containers in security context and needs to know that this is also set to false. And if not, you of course will get this message that says, hey, privilege escalation is not allowed. There's quite a few more things in here as well. For example, they also check this on higher level resources such as daemon sets, deployments, jobs, and so on. If the security context is set at that higher level, this is also checked in this policy. Let's now see what happens when I try to create a pod using this manifest over here. And of course you can see here that I specifically added security context and then allow privilege escalation true. So this should give me a error when I try to create this pod, right? The admission controller should kick in and should say this is not allowed. Let's try and do so. So let's do k apply -f, and then pod basic is fine. And of course, yeah, we get some errors. What we can see clearly is that, yes, this is an admission webhook, right? It's called validate.kyverno.svc. And it says, well, it's blocked due to the following policies. So more than one policy is actually an issue here. And yes, we installed a list of policies, part of the recommended pod security policies. So probably there's more going on than just this privilege escalation. But indeed, the policy I just shown you that checks for privilege escalation, this one here says, yeah, indeed, you try to do that. Privilege escalation is disallowed. You said allow privilege escalation is true, and you should not do that. But the list of policies also contains a check that actually says that running as root is not allowed as well. So you have to specifically set security context run as non-root. You have to set that to true as well. Let's try and correct these errors. Great, I opened the manifest with nano, sorry for that. And I modified the security context. First of all, I added the run as non-root. I added that and set it as true. But of course, allow privilege escalation is also not allowed. So I'm going to set this to false. In addition to specifying I don't want to run as root, I also specify the user ID I do want to run as. So run as user 10,000, run as group 10,000. That's okay. I'm going to exit this and I'm going to save this with yes. I'm going to clear this out. Then I'm going to use k apply, and I'm going to apply this pod basic YAML again, and hopefully this now works because I modified the security settings inside the pod. Let's check this. Yeah, it seems to be okay. Let's do a k get pods here, and indeed I see that my go template pod is running. Fine, so we've corrected the mistakes, and we've seen now clearly that Kyverno is using these policies to check what I can do. So the admission control part is clearly working. This is very similar to what we did with the Gatekeeper installation and Azure policy that also has this group of security policies that you can apply to your cluster. So it's very similar to that. But what if you want to provide some other guardrails as well to developers? So not just the pod security policies, of course that's important, but you also might want to specify other things. This is now a policy that you can also just download from the Kyverno website, which requires that you set limits. So similar to the other policy, it's a cluster policy, right? The rules here are rather simple. So we have in the rules, it's an array of rules, of course. We have a rule called validate resources, as you can see over here. We match this to pods. We have a validation message as well, as you can see there. So CPU and memory resource requests should be set. And then again, we set the pattern for our rule. So we expect that in the specification of our containers, we have resources and we set the requests and the limits here, and we can use wildcards in this case as well. So if we apply this policy, we'll do that with k apply and then the limits poll.yaml. This creates the policy, and I should of course put -f in front of that. Yeah, let's keep it in the video, no problem. -f. This creates the policy on our cluster. It's a cluster-wide policy in this case. That means that when I create a pod that does not contain these limits, I should normally get an error here. So I already passed the security policies, but now I have to also make sure I respect the rules of the cluster admins and I stay within the guardrails that they have set. Well, let's try this. So let's do k apply and then try to do the pod basic, because I already removed that pod from my cluster. When I do that, it says to me, well, no, that does not work. You didn't set CPU and memory resource requests. You need to set these limits over here. Great, that's very clear. The policy itself is very readable, very clear what it does, and indeed the guardrails for limits and requests have now been set. Yeah, how can I fix this? Well, actually I have another pod here, pod definition, which is pod.yaml, that contains a little bit more information. So it contains a security context, but it also contains resources. These resources do not make sense for this application, but that's okay. So resources, the limits and requests have been set over here. So now in this case, when I just exit this one and I'm going to do k apply -f and then just apply the pod.yaml, not pod basic, this should actually work because the limits and the requests have been set. Let's do k get po, and indeed go template, that's my pod, is now running. Okay, let's now look at a mutating policy. So you look at a policy here, again it's a cluster policy. The policy is called, as you can see here, add volume, and the idea is that we are going to look at resources of the type pod, and when the pod contains an annotation that is vault kubernetes corp.net inject equals enabled, and by the way this is a precondition, you can find this out in documentation what preconditions are, we're going to actually mutate the object. We're going to patch it, right? There are different ways to patch a JSON object, things like strategic merge and so on, but you also have this JSON 6902 RFC thing that you can use for that, where you can really be specific in the kind of operations you want to do on the incoming JSON. So in this case, we're going to add JSON at the path spec volumes, right? So the spec of our pod there, we're going to add at volumes a volume with a name called vault secret, and it's going to be of type empty dir. And of course, if we specify a volume, we also have to do a mount of that volume. So in our first container in our pod, so the first container, container 0, under the volume mounts, we're going to say, well, we're going to mount the volume we specified here under /secret, and the name of the volume we're going to mount is vault secret. Now, that's not really that important what we're exactly doing here. The main thing is that this is a policy that is mutating your existing request. That is something you couldn't really do with Gatekeeper. Now, let's take a look and see how this works in action. I'm going to first apply this policy. So k apply -f add volume pod. This creates the policy, the Kyverno policy, on our cluster, and it's a cluster-wide policy. As you can see, I already had it installed. It's unchanged. I didn't modify it. Let's clear this out. Let's take a look if we have our pod already deployed. Yeah, we already have it, so I'm going to delete it first. So k delete -f and then pod.yaml in this case, because I don't want this go template pod over there. K get pod, and indeed that's gone. Let's now take a look at what's inside the pod definition. The pod definition itself, as you can see, it does not contain any volumes. It doesn't have the volumes listed here. But I do have the annotation in the metadata. I have the vault, etc. set to enabled. So based on our mutating policy, volumes should be added to this pod, to our first container here, which is called go template. Let's check this out. Let's just create the pod. So k apply -f and then pod.yaml. We create the pod. That's done very fast. We take a look at the pod. Did it get created? Yes, it did. Let's do a describe of the pod. And indeed, that's go template. And when we describe the pod, you should see indeed here that there are, let's take a look, we have our container go template. And when we look at the mounts, yes, we have a volume mount /secret. So that volume mount was indeed added. And in the list of volumes, we see a volume called vault secret of type empty dir, right? So now we can see that indeed this mutating policy that Kyverno enables for us works whenever we're going to add a pod, in this case to any namespace. Now there's one last thing we have to do, and that's look at a policy that is going to create an additional kind of resource. That's a generate policy. So in this case, this is an example from Kyverno itself. This policy is again here, as you can see, a cluster-wide policy. It's called add network policy. And if you have a network policy plugin enabled on your cluster, you can of course use that to control network traffic. If you look closely at this policy, you will see that in the rules, the rule that we created here is called default deny, and it's going to match all types of resources which are namespaces, right? And we're going to use generate here. So that means when we create a namespace, we're going to create an additional object, in this case an object of type network policy. We're going to call it default deny, and if you know something about network policies, a default deny, we're going to select all the pods in the namespace, and we're going to set policy types equal to ingress and egress, but not define any rules. Of course, we have to tie this to a namespace. This network policy is a namespace bound object, and we can do that by using these parameters over here with Kyverno. So if you want to fill in the namespace of this object, we can take the actual namespace name from the initially created object, which was our namespace. So in the request, the object metadata name. Let's see how this works. So I'm going to exit out of this. I'm going to create this policy. So k apply -f np poll YAML, and then we're just going to create a namespace. So I'm gonna clear this out. I'm going to create a namespace that is I'll do it like this, k create namespace network policy test np test, right? And then do a k get network policies, and we're going to ask for network policies in the namespace np test. So normally if the generate policy works from Kyverno, we should see that there's a network policy in there that does the default deny. Let's check if that is indeed the case. And indeed we see that in our np test namespace there is a default deny network policy, right? We can actually take a look what the network policy has as content, so -o YAML, and what you'll see here is indeed in the spec of the network policy, we select any pod in this namespace, and we have policy type set to ingress egress, but no rules. So that means, yeah, traffic will not work. All right, we've come to the end of this video. So you have seen an example of Kyverno. We only touched on the basics, of course, and we've seen a couple of the different types of policies. So we've seen validation policies that reject incoming requests based on the rules that you've set. We've seen an example of a mutating policy that actually added a volume to our pod. And we've also seen a generation policy that created a network policy when we create a namespace on our cluster. There is much more you can do, but I hope you see how flexible Kyverno is. I really like it compared to Gatekeeper. You can do a couple of additional things, and if you're only using Kubernetes for policies, then this is a very, very good option to also evaluate. Okay, that's it. Thanks for watching, and see you next time.